Me. Where you at, Petra? Page 456, example 1. 456. All you have to do is multiply by 3,600 seconds. You've got 2 kilowatt hours. Okay, so okay, so I have to kind of follow along here. All right, I might have to go through this. Okay, small electric furnace connected across 117 line volt dissipates 2 kilowatts of power per heat. Okay, I'm going to start this from the beginning just so I can follow through, Petra. I haven't looked at this yet. So I've got a 117 volt line. And dissipates 2 kilowatts of power per heat. So power is 2 kilowatts. What is the current in the circuit? Okay, so power is equal to V times I, therefore in A, I is equal to P over V. So we change that to 2,000 divided by 117. And I get 17.094 amps. Okay, so there's A. B says, what is the resistance in the furnace? So power is equal to V squared over R. I wouldn't use the I here, okay? Just in case I made an error in the first one, I don't usually use it again, so I'm going to get R is equal to V squared over P. So my resistance then is going to be equal to 117 squared divided by 2,000. So I get 6.8445 amps. Okay. And then in C, what's the cost of operation for 24 hours at 10 cents per kilowatt hour? Okay, so in C then I'm taking my cost of kilowatts per hour, so 2 kilowatt hours times 24 hours times 10 cents, and that equals to $4.80. Okay, so in C, $4.80. And then in D, it says what quantity of heat in kilocalories is developed in 1 hour. All right, so I'm looking for Q now. And Q, I can use I squared RT over J. Where's my Q? Yeah. So let's use Q equals I squared RT over J. So my I is 17.094 squared. Resistance is 6.8445. My time is 3,600 seconds, sorry. My back to you. All divided by 4.19. And it is, I just want to see, it's my J. Joules per calorie. So I've converted all this. I'm just going to extend this down a bit. I've converted all of this already to, I never really work with kilos, with kilos. I like to work with this all in their base units. Okay, so I would get 1,718,373.652, and that will be in calories. So I could divide that by 1,000, and I get 1,718.374 kilocalories. Yeah. Okay. Does that help? Okay, no problem. Do you have any other questions this morning from physics or pre-calculus? Pre-calc, page 164, question 4C. Sure. Okay. Okay. So we are, I'm guessing, asked to sketch this. So the one thing that we haven't done near enough of is sketching these graphs without the use of technology. So I'm going to show you this morning, because we have some time here. I'm going to show you how I would go about sketching this and the order in which I would do it. So the first thing I do is I put down my A, B, C, and D. So A is 1.5. B is 3. I'll get to that in a second. C is negative pi over 2. And D is negative 1. Okay, so the first thing that I'm going to do is I'm going to draw my midline. All right, so, and then I'm going to label it. So I've got a coast graph. So my midline looks like this. I go here, And my coast graph, I'm going to draw in my 5 key points. So I start up here with my coast, goes down to here, there, and there. Okay, so I'm drawing the very basic shape of one period length of my coast, and I draw it about my midline. So step number 2 is to work with my C value. So I'm going to label my C value because that's where my coast graph starts at. So in this case, my coast graph starts at minus pi over 2. Okay, so I put that into my coordinate. The third thing I then do is work with my period. Okay, so my period is 2 pi over 3. So the reason that I do my period now is because I want to find out what these other 4 key points are. So this one, and this one along my axes. Okay, so to do that, I'm going to add 2 pi over 3 to minus pi over 2. So that's going to give me minus 3 pi over 6 plus 4 pi over 6. Okay, so I'm adding 2 pi over 3 to minus pi over 2 to get to this point right here. So I add those together, that gives me 1 pi over 6. Okay, so negative 3 pi over 6 plus 4 pi over 6 gives me 1 pi over 6. So now the next thing that I do is then I find out what my halfway point is in between these two. Okay, so to find out that, I would add them up and times them by a half. So minus pi over 6, or minus pi over 2 is minus 3 pi over 6 plus pi over 6. And then I got to times that by a half to find out what my middle one is right here. So that's 2 pi over 6. So that's pi over 3. So, sorry, did I do that wrong? I don't think I did that right. My halfway point would be actually, sorry, I'm going to subtract here to find it out. Okay, so I want the halfway point between minus pi over 2 and pi over 6. So I'm going to go 3 pi over 6 minus, no, sorry, 1 pi over 6. Minus that, which is negative 3 pi over 6. That's going to give me 4 pi over 6, which is 2 pi over 3, which is what I got here, and times that by a half. So this value right here is going to be pi over 3. Okay, sorry for the mess here. So I took this. I know that this distance is 2 pi over 3. So half this distance is pi over 3. Oh, I've got a mess here, Petra. Let me do this. I don't like the way this is looking. Oops. I need this. This period is 2 pi over 3. Okay. So half of that would be pi over 3. So I'm going to add half of that. So I'm going to go minus pi over 2. Add pi over 3. That's going to get me to here. Sorry about that. I made a mess of this. So I've got minus 3 pi over 6 plus 2 pi over 6. So that's going to give me what have I gone and done wrong here? I've really made a mess of this. Minus 3 pi over 6 is that. Add 4 pi over 6 because that is what that is. That gives me 1 pi over 6. So half of this is pi over 3. So 2 pi over 6. So that's going to go, oh, sorry, this would be minus 1 pi over 6. That's why. Okay. So I made a real mess of this. The distance from here to here is 2 pi over 3. The distance from here to here is 1 pi over 3. Okay, so now I have those 3 key points. I can find these 2 if I need to. All right. So that would be halfway in between here and here. Okay. I'm just going to leave them out for just a second. All right. So this distance here, this would actually be 0 right here. That would be halfway in between minus pi over 6 and pi over 6. And then this would be minus pi over 3 right here. Okay. So labeling my period is the next part. Okay. Now, at this very point, Petra, now I just need to mark off what my midline is and my amplitude. So number 4 is my midline value, which I could have done at the start, I suppose. And that is -1, because that's my D value. And then my period is 1.5 above that. So that takes me to 0.5 here. And then down here, that takes me to -2.5. Okay? And then the last thing that I do is I somewhat put in my axes to where they're going to be. So my axes would be here and somewhere about right there. And that's what my graph would look like. Okay? So let me just do this. I'm going to graph this. I'm going to graph it on here just to get a better visual of it. Okay. How do I get pi on here? That worked. Okay. Okay, so, all right, Petra, so can you see this? Hopefully you can see this a little bit better. All right, so basically what I've done is I have graphed from right here to right there. That's the part of the graph that I showed on my picture. Okay. So from here to here is starting at negative pi over 2, and that takes us all the way over to pi over 6. So that's kind of what my graph looks like right there. All right, so this is actually pi over 2 right here. Okay, this is negative quarter pi, so pi over 4, so that would be in there. Okay, so that's how I do it. Now the key to this is doing midline, my C value, my period, the midline. I could have done this without doing it a second time. I could have just done it with put my midline and then put my value in, my -1 right here. That's all that is. And then I label my axes. Now my axis is not that important when you're doing this. Okay? The most important thing is to have the 5 points graphed. So that's the first thing I do. I graph these 5 points first. I draw a line just to help as a visual, and then I label everything after that. Okay? Is there anything else I can help you with there, Petra? Where did I put that book? That number, all of that number 4, those 4 graphs in number 4 are important to you. You need to be able to, especially on the provincial exam, you need to be able to graph one of these on the exam without technology. So make sure that you look through that thoroughly on that 4, and then check your solution in the back of the book for it. Okay. Anybody else on here have questions? Okay, good stuff. And question 5 on page 180 as well. Okay, come on. For the week after as well. If we got done that booklet, Petra, that would be more than enough to do it. Like we can pick up wherever in physics, but in pre-calculus we have to get done those units in case we have to write that provincial exam at the end of the year. Okay.